Hello students, in this video I will discuss about the rotational spectroscopy of polyatomic molecules. Polyatomic molecules are the molecules that have 3 number of atoms or greater than 3 number of atoms. Before that, let us see for the diatomic molecules. The energy for the diatomic molecules given as B into J plus 1 minus D J square into J plus 1 the whole square, where D is centrifugal distortion constant and B is rotational constant. Selection rule for the rotational spectroscopy is delta G is equal to plus 1, and line position is also given here. D by B value is very small for the case of the diatomic molecule, and one example for the NO, how to find out D by B value for NO is also given over here. So in this way, now we have to see about the polyatomic molecules. So look at here how a molecule rotates. A molecule can rotate along the axis A, it can rotate along the axis B, or it can rotate along the axis C. So three coordinates are there. So there is a possibility for the molecule to rotate along the 3 axes. And the moment of inertia is if it is rotating along the axis A, the moment of inertia will be Ia. Along the axis B, then the moment of inertia is Ib. If it is rotating along the axis C, the moment of inertia is taken as Ic. So moments of inertia, moments means movement, inertia means rest. So if the molecule has got, the atom has got some displacement, there will be moment of inertia. So now let us see the classification of the molecules. The molecules are classified as linear molecules, symmetric tops, spherical tops, then asymmetric rotars. Examples for the linear molecules: carbon dioxide, acetylene, carbon oxysulfide. Example for symmetric tops are ammonia, CH3F, and then BCl3 are the example for the symmetric tops. Spherical tops, they do not have the symmetry. Spherical tops, example methane. Then asymmetric top, example water and then NO2. So for linear molecules, Ia will be equal to 0, Ib will be equal to Ic for linear molecules. For symmetric molecules, Ib and will be equal to Ic, but not equal to Ia. Ia will not be equal to 0. Spherical top, Ia, Ib, Ic, everything will be equal to 0 when it is symmetrical. Asymmetric rotars, all the 3 will not be equal. Moment of inertia along the axis A and along the axis B, along the axis C will not be equal. So this is how we can classify the molecules, and we can say about the moment of inertia. First let us take the example carbon oxysulfide. So it has got 3 different atoms in it: oxygen, carbon, and then the sulfur. The distance between the carbon and oxygen may be lesser than the distance between carbon and sulfur. So there is a point at the center given in red color, that is the center point for the rotation of the molecules. So if the molecule is rotating along the axis E, so there is no displacement of the atoms. So atoms stay in the same place. So moment of inertia is equal to 0. So when the molecule is rotating along C axis or B axis, there will be moment of inertia, and the moment of inertia are equal. So Ib is equal to Ic, and Ia is equal to 0, approximately equal to 0. Distance between C and O is given as RCO. Distance between C and S is given as RCS. There is a distance between the center point and the carbon also, that is given as RC. So next we can say an example. that is methyl fluoride. Methyl fluoride, two types of symmetric tops, oblate and then prolate. Prolate methyl fluoride is the example for the prolate. So here there is a possibility for the molecule to rotate along A axis, B axis and C axis. And for BCl3 also there is a possibility to rotate along A, B and C axis. But in this case IB is equal to IC but not equal to IA. IA is not equal to 0 because when it is rotating along the axis A, there is a movement of the hydrogen atoms. So IA is not equal to 0. In this case also IA is not equal to 0. But the molecule is planar in this case. But in the case of the methyl fluoride, the molecule is not planar. So for oblate, the molecule is planar. But if you look into the moment of inertia, the conditions are same for both the cases. Next, let us see about the spherical tops and then the asymmetric rotors. Symmetrical tops, asymmetric rotors. For spherical top, we can give methane to be the example. It's a highly symmetrical molecule, so no dipole moment. It is not giving any rotational spectra. In this case, the moment of inertia are balanced. IA is equal to IB is equal to IC. But in the case of asymmetric rotors, for example, water molecule, if you take and if you rotate it along the A axis, B axis and C axis, if you see, there is a movement of the atoms in it. But all the inertias are not equal in this case.